Hello, in this video we're going to show a custom study that we've created that is a part of a greater trading system, and this video will be interesting for anybody using the software Sierra Chart or anybody interested in trading in general. We're going to show how we had an old school version of this study, which was a study collection. It was basically studies based upon other studies that were allowing us to display this specific way of seeing something on our chart. What we've done now is we've created a study in Sierra Chart, a custom study that actually does everything that was being done by 9 studies previously, but it's in one study and it's only about 110 lines long, as you see it right here. So what we'll do first is show you sort of how we developed this study originally, what I call the old school version or the caveman version of this study. So this is the chart right here, and the study is a study that is made to provide a reference for the volatility in the marketplace. What this study is what we're seeing on the right side of this chart, which is being plotted on the value scale. And in short, what this study is first we take a standard deviation of a certain amount of bars. Then we put a moving average that is based upon that standard deviation. And the moving average is there in order to smooth out the data set that is being provided by the standard deviation. And then what we've done is we take the value of that moving average and we use that as sort of our deviation that we will use to plot on our value scale away from a certain reference point. In this case, the reference point we are using is the point of control of a volume by price of the last 4 bars of the chart. Now, that is something sort of arbitrary that we chose, but that can be changed at any time. You can base it on any reference you want. Okay, and there's also another number here towards the edge of this extension, and that's what we call the overshoot range. And what we're doing to get that value is we're taking half of the value of the simple moving average, and then we're adding that on top of the simple moving average. And basically that is showing us what we think is our overshoot range. Okay, so we want to just be clear about the fact that this is a study that is based on a reference for the volatility, and it's also part of a greater trading system. So there's a high chance that whoever's watching this, you're going to be missing context about our trading, and you may not really understand how this is used or why this would even be used. And you might even, argue against the fact that this is even useful. You might even say, well, this is total bullshit. But anyways, if you're just going to be here to criticize things, then, most people click on these videos to learn something new. So we're going to show first the old school version of this, study collection. And let's get started with that. So like we said, the first thing we have is a volume by price of the last 4 bars. And all we have here is displaying the point of control, which is in this case right here, which is 75 cents, 30 seconds. This market is the 5-year Treasury note futures. So this volume by price is configured to highlight the point of control here. So if we scroll down a little bit, we can see here highlight point of control until the end of the window. And then we go to the subgraph, and the draw style is a line at the last bar to the edge. So basically starts in the last bar until the edge. That is what we are using as sort of a reference point. Now, where the study sort of starts is with this standard deviation. So the standard deviation in this case is set to a length of 20 bars, but actually this is 21 bars, because if you want to get specific about it, it's actually due to the fact that this data index here is 0 based. So 0 is actually the first bar. So when you put it to 20, it's actually calculating 21 bars in total. And I'll show you the reference for that documentation afterwards. Okay, so the first thing is standard deviation, and that value is right here. You can also see it being plotted there. Next, we have a moving average, a simple moving average, which is based on that standard deviation, and it is taking 84 bars of that standard deviation with the attempt to smooth out the data set, because we found that the standard deviation sometimes is, when the market moves a lot, it tends to over exaggerate the standard deviation. When the market is not moving, it tends to underestimate the standard deviation. So we found that by putting a moving average on there, we were able to smooth out the data set, and it was more reliable in general. Okay, so moving average based on the standard deviation. So the next part of the study collection is actually plotting the values on the price scale like this. away from our reference point. So we used these studies in CR chart, which are native studies called the study subgraph add and study subgraph subtract studies. And what this study does, it's a great study. In this case, we set an input data. So it's actually based on, in this case, because we want to use the reference for that volume by price study, point of control, we based these studies on that volume by price study. Then we select the input data, which will be one of the subgraphs from that study. In this case, it's the point of control. And then we have to type in here the amount to add or subtract from that input data. And it will plot that on the price scale. And that's what we've done here. So we have basically 4 instances of this study. So for example, these 1V, so this would be the one, I guess, standard deviation. What we do is we take the value from the simple moving average and we put it into the amount to add and the amount to subtract. And it plots that value continually, the specified amount, away from our reference point. Now, here was one of the issues I ran into with this, because on certain markets where the volatility is constantly shifting, right, I was having to go in and always set this value to whatever it was spitting out here. So I actually asked a friend of mine to code up a quick study for me, which was this one, which was a study value into a study input. And basically I'm using this custom study to select the source study, which is the moving average value here. So we get the moving average and then the average, which is the subgraph of that study. And we are taking this value and putting it into a target study, or 2 target studies in this case. And the target study in this case is the study subgraph add and study subgraph subtract studies. And we're also targeting input number 2 of that study, which is the input where you have to set the value or the number to subtract or add from your reference point. Okay, so if you guys are still with me, we're almost done here. And then we have the overshoot range or the extension. So we have another 2 instances of the add and subtract study, except that these ones are based on the previous study subgraph add and study subgraph subtract studies. And what we're doing is we're adding or subtracting half of the value of the simple moving average from that to plot what we call the overshoot range. Okay, so like we said, 2 more instances of the study subgraph add and subtract, and also 1 more instance of the 2 study values into study input custom study. And this one is putting the value from another study, which is giving us the result of half of the SMA. It's taking the value of half the SMA and it is adding that on top of the previous extension we had here. Okay, so if you guys are still with me on this, now we're actually going to show how we managed to create one study that did all of this. Now, some of you guys are going to say, wow, you actually went through all this trouble just to create an overlay onto the chart of your volatility range. And I guess it's pretty insane when you look at this and the way I just explained it to you guys. It literally seems like I was explaining to you guys like a fugue or like a counterpoint section out of a piece by Johann Sebastian Bach. And I guess that's pretty much what it is, because this is a smaller component of a greater trading system. And we actually are using this as sort of a part of a backbone that will eventually become part of an automated trading system that we're developing. Okay, so now we'll go over and look at the new study we created that does everything we just described, but it's in one study. It doesn't really matter what market we're on, but we can display this on any chart. We'll use NASDAQ futures as an example because the volume shifts around in this one quite a lot, and the volatility also changes quite a lot. So we have a chart for NASDAQ futures, and I'll go onto the studies of the chart, and you can see there's only 2 studies on this chart. There's the single volume by price study, which we're using as our reference, and then there is this new study we created called the volatility overlay. This study has 4 inputs. We have the input data for the standard deviation. We have the length for the standard deviation, the length for the moving average, and then the selecting of the source study to reference as our reference point to plot the other 4 subgraphs on the chart. We'll now go ahead and show you how this study is made. So we'll start here. Now, the first thing I got to say, guys, is that I am not a programmer. So for sure, I'm going to say things incorrectly at times. So just, don't hold me to that. But basically, the way I built this study was by referencing the code from the other studies and sort of piecing things together very slowly and a bit of trial and error as well. And yeah, so let's start it off. So we start by declaring our study subgraphs and study inputs here at the top. And then we set the defaults. In this case, the study has a graph name, a volatility overlay. The value format is set to inherited from whatever it's set to on the chart. The graph region is 0, which means it will be in graph region 1. And then for this study, we left auto looping on. And then over here, we have set all the defaults for our subgraphs and our inputs. And the deviation and the average, really, these are not even really being displayed on the chart. What we have, more importantly, is these 4 subgraphs here. So we'll continue going down and show the other inputs here. So here are the inputs. We set defaults for those as well. And then it begins the calculations for the study. So the first function is sc.datastartIndex, and this comes from the standard deviation study. So it's important to read through this to understand how the function works, and it's great that they really document all of this. So set sc.datastartIndex to the index of the first element at which subgraphs should start to be drawn. This is to prevent Sierra Chart from drawing elements at the beginning of the sc.subgraph arrays that do not have enough prior data to be properly calculated. For example, if you have a 10-bar moving average, this value should be set to 9. It should be set to 9 instead of 10 because array index values always begin with 0. So that goes back to the thing I said before about when you set your moving average to 20, it's actually calculating 21 bars. Okay, and again, I don't know the technicalities behind it, but that's just the way it is. So what this is basically telling the compiler to do is get the integer that is set in the input right here. So sc.datastartIndex equals this input dot get the integer from that input that has been set. Okay. Then we have the function for the standard deviation. So this function is pretty simple. It calculates the standard deviation of the data you're putting into it. And it has 3 fields that you need to fill in here. The first one is the float array in, then the float array out, and then the length of it. So float array in is where the input data is coming from. So what we're basing the standard deviation on. In this case, it's sc.basedDataIn, the input underscore data input dot get input data index, which is basically this right here. And it's set to sc underscore last. And this was pretty much a template from the standard deviation study already. So the base data in for the standard deviation is the last traded price for each bar. The next thing is the float array out, which is where we're outputting that to. We're outputting it to the subgraph, which is called subgraph underscore deviation. And then we're telling it that the length of the study should be the length set here. Input underscore sd length dot get integer, which is set right here, 20. Okay, and what that does is it calculates the standard deviation. The next thing I needed to do in the study was calculate the simple moving average, but make sure that it is based upon the subgraph underscore deviation. So Sierra Chart also has a function for simple moving average. And what this one does is it calculates the simple moving average study. That's all it does. And it has, again, 3 parameters you got to fill in: the float array in, float array out, and the length. The index parameter only needs to be used if your study is manually looping. In this case, my study uses auto looping, so it's fine. So the float array in for the simple moving average is set to the subgraph underscore deviation, meaning that the input data for the moving average, or it is based upon this right here. It's based upon the subgraph underscore deviation. The float array out is outputted to the subgraph, which is subgraph underscore average. And then the length is being taken from the input underscore ma length dot get int, which is set right here. What these 2 things are doing right here is it is calculating, number 1, the standard deviation, and then it's calculating moving average based upon the standard deviation. That's all. Okay, if you guys are still with me, remember to smash like on this video, because actually this video is for anybody out there who needed motivation or confirmation that anybody and their grandma can learn how to code if they're stubborn enough and motivated enough to get something done. I have no prior experience in programming at all, except for just a bit of trial and error and watching other coders do a few things and learning, So just motivation to you guys. If you want to learn how to do this stuff, you can easily learn how to do it if you're stubborn enough. Okay, so the next thing we have to do now is do some more calculations to eventually calculate and plot the other 4 subgraphs on the chart, which are the extension high, extension low, and overshoot low and overshoot high on the chart. And of course, that is not all of it, because next we plan to use this as sort of the basis of an automated trading system and automated order management. Let's go on. So the next thing we do is we declared a float and we called it SMA, which is equal to the value of subgraph underscore average of sc.index. Okay, so the next thing is a little tricky, so bear with me. We have this input right here, which has an input array to it called set study subgraph values. What this is basically used for is to make reference to another study ID and subgraph that is on the chart already. In this case, this is the input we are using to select the ID and subgraph of that particular volume by price study. And we're using that to base our other calculations on. So if we go ahead and first go to the Axel documentation, interface members, sc.input array, there's all kinds of different input arrays you can set. One of them is this one, which is interesting. This study works in conjunction with input.getStudyID to get the select study's unique ID and input.getSubgraphIndex to get the subgraph index. So we use this input array to make a reference to another study on the chart. So this is how it's set here. Default, it's set to nothing, which means we're not setting a default of which study ID to select, but in the case that we know already which study ID our particular reference study will be, we can actually set it right here. So if we know on our chart that the volume by price will be study ID 2 and the subgraph will be subgraph 2, we would set it in these defaults. And since it's 0 based for the subgraphs, at least, this would be set to subgraph 1. Next, we'll show how this is used. So we grab the source study ID and the subgraph from the input, because remember, we put that into the input right there. We declared 2 separate floats here, one for the study ID and one for the subgraph ID. And these will be used to make reference to the source study subgraph next here. So source study ID, which is what we called it, is equal to input underscore source study and subgraph dot get study ID. And then the next float is for the subgraph, so we called it source subgraph ID, is equal to the input underscore source study and subgraph dot get subgraph index. And here's the documentation for those particular functions. So next we have this function, which is used to make reference to the source study subgraph, which is this function right here, sc.getStudyArray using ID. And it has 3 parameters to it. The first is the study ID. The second is the study subgraph index. And then the third is the float array reference, or the subgraph array. So this block here came from a template that is provided by Sierra Chart, but I took it from the block that Frozen wrote for me in the other study. And it turned out that it worked perfectly here as well. So we have SC float array study reference. I don't totally understand this line right here. And then we have our statement of this study. So if sc.getStudyArray using ID, we have source study ID right here, which was our first floating point value. Then we have the source subgraph ID, which was our second one that we're getting from the input, by the way. And then we have the SC float array, which we called study reference. The next thing is grabbing the source study subgraphs array. So another float, we called it based on study subgraph value. And that is equal to study reference of sc.index. But I know that this is making reference to the data from the study that I'm targeting. So the SC float array called study reference is basically encompassing the array, which is a set of, I guess, data from the source study subgraph. And then what we're doing with that is we're declaring the float of that array. I guess that's how I can explain it. Okay, and then the next thing is we finally make the calculations and we plot the subgraphs on the chart. So subgraph underscore low of sc.index, that's the name of the subgraph, is equal to our study reference value, which is there, minus SMA, which is our other floating point value. And that is giving us the first subgraph, which is subgraph underscore low, which is this right here. This one right here. The next subgraphs are pretty much the same. The subgraph underscore high of sc.index is equal to our reference study subgraph plus the value of the SMA. Then we have our overshoot ranges here. Subgraph underscore overlow, which is the name of the subgraph of sc.index, is equal to the value of our reference study subgraph minus half of the value of the moving average minus the value of the moving average. And that is giving us our overshoot range low. And then we have the final subgraph here, which is subgraph underscore over high of sc.index is equal to the value of our source study subgraph plus half the value of the simple moving average plus the value of the moving average. And that is giving us our final overshoot high. So these subgraphs for one volatility low and one volatility high are being set away from our reference point by the amount that is being spit out by the simple moving average. The simple moving average is based on 83 bars of a standard deviation that is taking 21 bars of the most recent data on the chart. And then these further overshoot extensions are simply taking half the value of that moving average and are putting them as an extension because that is what we categorize as our overshoot range, approximately. Okay, and that's our study. I hope we did a decent job explaining it. And honestly, if you made it this far in the video, you're probably like 1 in a million. But the next step here is going to be to use this study as a basis point to do some automated order execution and trade management here. We're actually going to probably base a system on this if all goes well. So we'll see you later. Take care. Thanks for watching. Bye.